probably we can just shift into some sort of like an audio only type of mode. I'm not sure whether your connections would allow you to open up the cameras, especially in an introductory session or not. That depends on where you are and how the reliability of the network connection or the internet connection that you have. The course, as you see the syllabus I'm sharing, actually I shared a couple of files in the Blackboard. One of them is the syllabus, you can see it in front of you, and the other one is the introductory presentation. We are going to have presentations. I'm going to make sure that the presentations are available beforehand so that you can have a look at the presentations before we get started to that lecture, and it will always remain there. The catalog description of the course would be talking about thermal aspects of solar energy conversion. When we are talking about energy, then we are very much interested, as you have seen in thermodynamics, of how to convert that energy to something useful. And having something useful, this is related to be either heat or electricity. Solar radiation is an essential part of the course. And I would assume that you have covered a part of the solar radiation, at least the introductory part of solar radiation in heat transfer course, both in mechanical and chemical engineering courses. There's heat transfer, and a part of it is related to solar radiation. Then there are selected topics of heat transfer that we are going to cover. Basically, we are interested in thermal radiation. In many cases, we'll be interested in convection heat transfer as well, because if we are going to talk about solar collectors and PV panels, then there is some sort of a cooling effect that's coming from the air. Flat plate and focusing collector analysis is something which is an integrated part of the course, where because this is actually the applications of solar energy. And then storage of solar energy is an important topic that we're going to talk about as well. And that is covered in terms of either the storage is going to be done through storing the heat energy or storing the electric energy in the form of batteries. Then some systems where we can apply what we have learned from the solar energy on are going to be discussed, and basically the systems are going to include hot water, space heating and cooling, distillation, where we can use the solar energy to get desalinated water, and definitely power conversion in the form of electricity. So this is some sort of a quick overview of what is expected to be seen in this course. The prerequisite to the course, it's we're writing here 315, but it's 315 or equivalent, which means that it's a course of heat transfer basically. The textbook, I would assume that you got or you will get the textbook. If I can show it in front of the camera, this is the textbook that we are using for the course, which is, as you can see here, it's Solar Engineering of Thermal Processes, 4th edition, and this is by Duffy and Beckman. This version is located or it's available in the bookstore. I just received it yesterday, and you must have tried in the previous semester that you could be able to receive the textbook that will be mailed to you. That's something the university is going to take care of. Until that happens, you are going to rely on the presentations that are going to be shared with you in the Blackboard folder. So that's why you are frequently requested to be looking every now and then on the Blackboard folders just to see what are the updates. I would assume that you will be notified by emails, so that you are going to get emails to indicate what are the news. If any file is updated, you will get some sort of a notification through the email to get in, like the one that you got from the announcement I posted yesterday for how to log into the course. We are going to use Microsoft Zoom, as you can see here. I set it up in a way that you have to go through registration only once. And then from now on, from the next class, you should be able to get in easily without a need of further registration. Now, we talked about the textbook. There is a reference if you need the reference. Otherwise, some sort of needed materials I'll be going to provide through the Blackboard as a source. Why do we need the course for? It's basically to enable you as senior mechanical and chemical engineering students to be able to estimate the solar radiation integrated into an overall design of a thermal system. Suppose that I need to do some sort of water heating, which is needed for space heating in buildings or needed for desalination purpose. Or you might need to heat the air, and heating the air can be done for space heating as well. You need to have hot air in winter times, especially in the cold climates of the kingdom that can be seen in the north as well as in the south. Or in other applications, you may need to heat water to convert the water into steam and make use of that steam in a power plant. Alternatively, you may need to have conversion, as I mentioned, from the solar energy into electrical energy that you can use it to run any appliances that you have. The prerequisites by topics, the information, or are going to base the course on some sort of foundations that you have learned earlier that would include the first and second law of thermodynamics. First law of thermodynamics is basically the energy conservation. The second law of thermodynamics is talking about the quality of energy. Part of it is that we know that energy can be transferred from a high level of energy to our lower level, like talking about heat can transfer from a higher temperature to a lower temperature source, not vice versa, unless we do work on it. Black and body radiation interaction is something that is a foundation that we are going to build on, in addition to your ability to use the computers. And by the computers here, I mean as simple as the Excel file, going to a little bit more in depth, going to either MATLAB or engineering equation solver, that we will try as much as possible and early enough to make it available for you to log in. But as long as Excel can be used, that's a good enough tool to begin with. The topics of the course, you'll see here, there are two versions of the course that are available by or offered by our department, Mechanical Engineering, for this semester. One of them is a course which is running on Sunday, Tuesday and Thursday, which is taught by Dr. Bilal Qureshi, and the second version of this one where we are meeting twice a week on Monday and Wednesday, and the class duration is 75 minutes, as you see. So based on that, we are going to meet 30 times during the semester, and here are the topics which are roughly distributed over these classes, starting with solar radiation characteristics, and then the measurement of solar radiation, estimation of radiation, selected topics in heat transfer as some sort of a revision to prepare you or to remind you of these topics as we get started to the course, characteristics of radiation of opaque surfaces, and then radiation transmission through glazing. And glazing, we mean by that is glass. And you will see in most of the cases, the solar collectors are covered with glass. Then getting more specific into applications, talking about flat plate collectors and concentrating collectors, storage of energy, and then solar thermal calculations. We're getting into solar energy being a part of the whole system. And then through these applications, we are going to cover some topics which are related to, as I mentioned, collectors, PV panels, as well as some other applications that will be having those as a part of. And then there is one class which is going to be, or the time of the class is going to be dedicated to the midterm. As far as I understand so far, we are going to have a single midterm where you will be coming to the university yourself to take the midterm in addition to the final exam that will be face-to-face as well. Otherwise, any kind of assessment, it's going to be done online. So quizzes will be done online through Blackboard. The homeworks are going to be assigned regularly. They will be submitted on time so that no late homeworks is going to be accepted. And there's some sort of standard policy which is related to the attendance that is given here. And the kind of, I wouldn't say threat, but basically there are some sort of regulations of if excessive absences are which are unexcused, then they are going eventually to lead to a DN grade. The evaluation of the course is going to be given as follows. A midterm exam is going to bear 25% of the grade. Quizzes will have 20%. Homework will bear 10% of the grade. There are special assignments that could be one or more small projects that you can do, or maybe open-ended problems that are going to have a separate weight of 10%. The final exam is going to be 35%, and that sets a total of 100%. For the special assignments, I would think that it would make more sense that you can do it as groups, which means that down the line sometime, not too far from today, I'm going to ask you to form groups and give me the names of your groups. Maybe groups of 3 each is going to be good enough to start with. Some sort of general information that you are urged to look at the Blackboard every now and then for any updates. Although I would, as I mentioned, I would assume that you are going to receive some notifications through the email for any updates that would happen through the Blackboard. But in case the notifications are not running, you may need to have a look at the Blackboard every now and then. Calculators should be non-programmable. Actually, in exams, we are going to provide a formula sheets ourselves. So for the formulas that are long or the formulas that you should not memorize, then these should be provided to you in exams. So you don't have to store it in calculators. And that's why the non-programmable calculators are the ones that would be allowed, at least to make sure that you have some sort of a fair treatment between every one of you. Something goes without saying about cheating as well is given here. So this is some sort of a general outlines of the course, and then I would close this this file of the syllabus unless you have any questions or comments. It's probably time again to close this. Yes.
Is there any possibility to rechange this syllabus? Because it's too much, 60% for midterm and final exam.
The point is, previously we used to have something like a certain smaller percentage where we have 2 majors. Now the regulations are clear from the university that it's got to be a single midterm and a final exam. Maybe if you wish, we can reduce the midterm to something like 20% and move the 5% into the special assignment. So if it's fine with every one of you, then that should be okay. Just think about it, and then maybe I can get you feedback maybe next class or the class after that when we are sure that everyone is here. Now I see that you are, what we hear is just 18 participants, 3 are missing. I'm not sure if they are going to join us or not, but when the dust settles of the semester, then we can reconsider this. I'm flexible in that. So that's something that we can do.
I think that's a good idea, Hector. Thank you.
Okay. Then I'm going to stop the sharing right now. And before I move on to the presentations, I would just quickly call on your names.
Doctor, I have one question, please.
Yes, go ahead, please.
What's the due date for the midterm and the final?
This is something which is going to be decided by the registrar, so that we are going to make sure that there's no conflict between this and any other substances, any other subjects that you have. So usually we used to set the times ourselves, and then we are going to have some sort of a conflict between other subjects. So that's why it will be this way. It will be handled by this registrar this semester. So once I get these values, I'm going to these dates, I'm going to share them with you. At least it will release us from the burden of worrying about whether you are having other exams at the same time or not.
Doctor,
Yes.
some of us had take ME315 for like 3 semesters. So can you like revise us the important?
Yes, actually, there is a part in the course where we are going to revisit, especially the issue of radiation in 315. I would urge you to go ahead and read this part, and then when it comes to it, I'll try to cover it quickly as we are moving through the topics that we're having this semester.
Okay, thank you, Doctor.
Urge it to reread it again, and then you will be reminded when we get to these subjects. All right. Further questions or concerns? Okay, then let me call the names, and I have to tell you that I'm going to check the attendance something like 5 minutes after the class. And I might be calling the names randomly at any time during the class as well, just to make sure that in the last 20 minutes you were able to see me. I was not able to see you. So if we cannot all open the cameras, then I'll just to make sure that you are with me already, and hopefully you did not fall asleep as in the middle of the class. So I'll be from time to time calling the names for one or two of you, so that to make sure that you're following up. Abdul Hadi, Abu Zaid.
Yes.
Okay, and Abdullah, Abu Shaya.
Yes.
Abdul Rahman Al-Mashhaf. Please correct the name if I'm not pronouncing it correctly.
Yes, المشهف.
Okay. Yusuf Al-Muhaish.
Yes, Doctor.
Okay.
المحاش.
Al-Muhaish. Okay. Ammar Thumali.
Yes, doctor.
Okay, mashallah, Ammar was the first one to log in today. Just when I logged in, I found him waiting. Hussein Al-Wahid.
Yes, Doctor.
Okay. Saleh Al-Blahi.
Yes, Doctor.
Abdullah Dosari.
Yes, doctor.
Majid Al-Hajri.
Yes, doctor.
Omar Al-Juhani.
Yes, Doctor, here.
Abdul Aziz Al-Maqthawi.
Yes, here.
Omar Al-Shamari.
Yes, doctor.
Abdul Aziz Al-Shihri.
Yes, doctor.
Rayyan Al-Wadai. You've just been admitted, Rayyan. I would assume that you are here.
Yes, Doctor.
Yeah, and I mentioned Rayyan, so I'm going to check after 5 minutes from the beginning of the class. Fahad Al-Zahrani.
Yes.
Omar Bajaba.
Yeah, present.
Nawaf Al-Ka'bi. Nawaf Ka'bi. Okay, Ahmad Khawaj.
Yes.
Ahmad Sindi. So he's not. And Yasser Shaidel or Shiadel. Can you correct it to me, Yasser? Maybe he's not here as well. Okay. All right. Okay, now moving to what we need to consider today as a part of the topic that we have. Yes, I can see that you are. I see your name here, but I'm not listening. I'm not hearing you.
Doctor,
Yes.
pardon me, can you say it again what you said for me, for Riyadh?
Oh, I'm just saying that I'm just saying some sort of the system that we are going to do that. I'm be checking the attendance 5 minutes after the start of the class. So please make sure all of you that you can join on time.
Okay, thank you.
And I was calling on Yasser, but I haven't heard his voice so far. Because I see his name here, but he did not respond to me, so I considered him absent. So, oh, so your voice is not there, Yasser? I mean, you have a problem with the mic, maybe? Hopefully you'll be able to fix it so that we can just get your interaction later, okay? Fine, I'll adjust the attendance to make sure that you are counted in. So Yasser is present. Okay, now getting to the topic, we are going to begin with looking at this is some sort of a standard screen that I'm going to go through throughout the semester. Why solar radiation? Why are we interested in that? The sun is too far from Earth. The distance is so large. You can see it here. It's given something like 93 million miles, and we'll get that into the SI units in terms of kilometers in a couple of slides. So despite that there is a large distance from the sun, but there is enormous solar energy which is reaching the Earth. More than continuous 1 kilowatt per meter square. Actually, it is something like 1.368 kilowatt per meter square. It is reaching on the outside of the atmosphere. Whatever is reaching outside the atmosphere, we call it extraterrestrial. So we have extraterrestrial power in the form of 1,368 watt for every meter square is reaching outside the atmosphere. Why I'm keeping saying outside the atmosphere? Because as the solar energy gets to the atmosphere, it gets a little bit distracted, which means that part of it is going to be reflected. We have some sort of humidity in the air, so it absorbs some of the energy. We have some dust particles which reflect part of the energy. So what we are getting in the ground is less than this value. But this value, which is reaching to the tips of the atmosphere, to the outside of the atmosphere, is a constant value. And this constant is referred to as a solar constant. On the Earth's surface, the average daily interception is 4 kilowatt hours per meter square. And please, while we are moving, just focus on the change of the units as we are moving from one quantity to the other. I was talking previously about a solar constant, which is talking about how many watts per meter square, but then which is 1,368 watt per meter square. And by the way, this value is not a sacred value. It's not a value which is constant. It's almost constant, although they call it the solar constant, but evaluating this value has changed it from one source to the other. Some scientists came up, said that the value of the solar constant is 1,365. Some said, no, it's 1,342. So this kind of variation is within a very small percentage, and in this course, in this book, we are going to consider it as 1368 watt per meter square. The second quantity you have seen here, the interception falling on the earth, it is 4 kilowatt hour. It is 4,000 watt hour per meter square, which means that now this is multiplied by a certain duration. Why I'm saying that? Because somebody, when he's looking at this number for the first time, he would say, we say that the solar energy reaching outside the atmosphere is the solar constant, and this is the highest. How come the quantity is 4,000 on the ground? So the answer is that up there, it is rate of energy, which is energy per unit time. This is watts. Watts is joule per second. But the second one, it is energy into time, so kilowatt hour. If we can even convert that into kilojoule easily, because the hour is 3,600 seconds. So I can convert that into kilowatt second, and then which is a kilojoule. So here we have the quantity of the energy or the rate of the energy multiplied by the time. The solar energy is intercepted by the Earth in a month is equivalent to all the energy stored by conventional means on the planet, whether it is coal, فحم, petroleum, petrol, or natural gas, غاز طبيعي. So we're talking about a huge quantity of energy. As a matter of fact, in some other books that are talking about the energy conversion, for example, they are going to see, you're going to read that the solar energy is the source of all forms of energy that we see in front of us. Definitely, it is a source of the wind energy, because as the solar energy is there, it heats areas in the air, other areas are colder, so that leads to the convection currents, which are generating the wind. It is responsible for the tide, which is happening in the sea. So the ocean waves energies are originating from the sun. So wind energy from the sun, ocean energy from the sun. Not only that, but actually is the analysis of the old materials, al-hafriyat, over hundreds or thousands or even millions of years has resulted in the natural source of fuels that we have, like the coal, the petroleum, and the natural gas. But this is occurring on a very long span of time, where others, like the wind energy, is spontaneous. That's something which is occurring just at the instant. However, we are looking now as we are using gasoline, which is a part of the oil or the petroleum, and this is extracted from the earth. However, this is depleted, which is mean it is not a continuous source of energy. More or less in 100 years or more or less, this quantity can be depleted or decreasing to the level that would be diminishing. Some theories say it's not true. Some theories, other theories said no, it's 250 years. Some other are saying that it's only 50 years. Now it depends from one location to the other throughout the whole world. But the point is, it is not a kind of a renewable source, or actually it needs millions of years to be renewed again. But the sun is rising every day, and there is a great potential. Look at the area of the kingdom, which is more than 2.2 million kilometers square. And being in a place which is rich in solar energy, that would make a very good potential for utilization of this solar energy for many, many of the applications that we are doing. So we are serving the atmosphere by reducing the carbon dioxide emissions going into it by using the petroleum sources, and keeping the petroleum sources maybe for export, so that it makes like a source of income, and making use of the current huge or tremendous quantity of solar energy falling. Before I move on again, that's when we're talking about why solar energy, there's an important rule here which is called the inverse square. It's some sort of, originated from the physics as usual, that states that the irradiance, which is the radiation per unit area coming from the sun, is reduced in proportional to the distance. So the longer the distance, the less the solar energy that we might be receiving. Now, let's have a quick look on the contents of the course. We did that quickly as I was looking, we were going through the syllabus together, but either for those who joined us a little bit late or for getting a little bit, or to get a little bit more of an insight, let's go through it again. Now, the basic ideas and calculations that are essential to understand are going to be covered in the first 5 chapters of the book. So the first 5 chapters are basically some sort of an introduction. I'll just here quickly mention the title of this chapters. Chapter 1 is about solar radiation. This is general introduction. Chapter 2 is about available solar radiation. Then Chapter 3 is talking about selected heat transfer topics. Chapter 4 is about radiation characteristics of opaque materials. And Chapter 5 is talking about radiation transmission through glazing, which is glass basically, and how it absorbs the radiation. So this is basically the kind of foundation that has to be laid in the first 5 chapters. And then Chapter 6, which is now the heart of the matter, is to start to talk about flat plate collectors. Chapter 7 is about concentrating collectors. So which means that in the first 5 chapters, we're understanding about radiation, we're understanding about the geometry, the nature of the geometry between the Earth and the Sun, and how does this changes in the geometry and the rotation of the Earth around its axis and around the Sun with a certain eccentricity and a certain slope is going to result in changes. Actually, it is the changes between day and night and changes between the seasons that we have over the year. Once we understand all of that and try to make use of it to estimate how much energy is falling into the ground of any location in the kingdom or in the whole world, and how this is going to be affected by the slope of the solar collectors that we are going to use, then we will be ready to look at the applications. Like if I have a flat plate collector, then I should be able to estimate how much energy is falling into that collector. Because based on that, I can see how much energy is transmitted and how much is the load that this collector can take care of. So this kind of foundation is going to be laid in chapters 1 to 5. In chapter 6, we're going to develop the equations, which is related for the collectors, so that we can see how the useful energy can be obtained. First chapter, again, is talking about the nature of radiation emitted by the sun and its incidence on the Earth. Talking about the geometric considerations, beam radiation, for example, received, the angle of incidence of various surfaces, quantity of radiation received over a certain time span, how does it change over the day from 1 hour to the other. The second chapter is talking about the effect of the atmosphere on solar radiation and radiation incident on surfaces of various orientations accordingly. Chapter 3 is basically related to heat transfer basics that are basically related to solar radiation. Chapters 4 and 5 are basically talking about the interaction of radiation and opaque and transparent materials. When you are designing a solar collector, the top of the solar collector is made of glass, but the receiving part of the solar collector is made of basically metals, which are opaque. So the issue here is related to how the energy of radiation coming from the sun is received and transmitted through the glass and how it is received and absorbed by the opaque material. So these 5 chapters are leading to chapter 6 that has a detailed discussion and analysis of the performance of flat plate collectors. Then moving one step forward from the flat plate collector to the concentrated collectors. The concentrated collectors could be the evacuated tube collectors or the parabolic trough or the paraboloids, or which is called the solar dish. So these are the types of collectors that are used for high temperature, high energy needs. Energy storage is considered in chapter 8. Chapter 9 is talking about the loads imposed by solar processes and the information that needed to analyze these processes. Chapter 10 is getting into individual components brought together in a system level. And that basically is to enable us to predict the performance quantitatively in terms of numbers, not qualitatively in terms of higher and lower, but we need numbers so that if you need to design a certain system, then you require a certain amount of energy. Then I should know, for example, in order to produce a certain amount of kilowatts, how many solar collectors should I use? What is the right type of the solar collectors based on the temperature that I need? So putting these elements all together is going to be there as a part of this chapter. So this is some sort of, again, of a walkthrough the course details. And right now we're going to begin in the solar radiation as given in chapter 1. There's something that I'll be doing. Actually, what I'm going to do here is that I'm going for a while to stop sharing. And for a while, I started recording the lecture, by the way. So right now I'm going to stop the recording